Hey everyone, this lesson is on multiplying polynomials. FOIL, you may have heard that phrase FOIL before. So we're going to be multiplying polynomials. We'll first start with multiplying a polynomial by a monomial. Recall the distributive property. A times b plus c inside the parentheses is equal to a times b plus a times c. To multiply a polynomial by a monomial, multiply the monomial factor in front of the parentheses by the factors of each term inside the parentheses. Use the distributive property and the rules for multiplying monomials. So a monomial is just a single term, and a polynomial could be 2 terms, 3 terms, 4 terms, etc. Alright, so here's our first problem. The directions could say find the product, or it could just say simplify. In math, we like to do that a lot. Simplify. Okay, so the monomial is 2x to the third y to the fifth. That's our monomial. And our polynomial is actually a trinomial. 3x to the third y squared minus 2x to the fourth y plus x. So we're going to distribute that monomial by each term inside. So first we're going to multiply it by the first term, and then the second term, and then the third term. All right. We're going to show all the steps here, but if you don't want to show everything, if you want to go right to the answer, that's totally fine. All right, so let's multiply that 2x to the third, y to the fifth by each one. So here we go. So that's showing each one. Notice that I kept the sign in front of the second term, the minus. Okay, so the first one is going to be a positive because they're both positive. The coefficients are both positive. So 2x to the third y to the fifth times 3x cubed y squared. Multiply the 2 and 3, that'll give you 6. And then when you multiply, you add the exponents. And then the next one, think of it as a positive 2x to the third y to the fifth and a negative 2x to the fourth y. That second term is a negative because of that minus sign in front. And then the third term, when we multiply the monomial times x, we're going to get a positive. And the exponent on the x is just 1. Right, so there's your answer. 6x to the 6th, y to the 7th, minus 4x to the 7th, y to the 6th, plus 2x to the 4th, y to the 5th. All right, let's try another. So that last example was a monomial times a trinomial. Now we're going to talk about multiplying two polynomials. So we're going to use the distributive property to distribute the first term of the polynomial by each term of the second polynomial. Then distribute the second term of the first polynomial by each term of the second polynomial. Continue this process if the first polynomial has more than 2 terms. Then combine like terms. So we're really going to just distribute, in this case, twice. Okay, so you're going to distribute the first term. So forget about the second term. You just go ahead and distribute the first term to the second polynomial, and then you go back and distribute the second term. Sometimes people will call this FOIL in this problem, but we're really just using the distributive property. All right. So x times a, and then we're going to do x times negative 2b. Then we're going to go back and multiply 3y times a, and then 3y times negative 2b. So x times a plus x times negative 2b plus 3y times a plus 3y times negative 2b. See what this works. So we're multiplying x times a, and then we multiply x times negative 2b, and then we come back and multiply 3y times a and 3y times negative 2b. So x times a is xa, but we like to put the variable in alphabetical order, so ax. The next one's going to be a negative because it's a positive times a negative. The third one's going to be a positive, and the last one's going to be a negative. So ax minus 2bx plus 3ay minus 6by. Okay. Again, we're going to do the same thing on both these problems. You can always pause and work them out yourself. Okay, so remember, we're going to do the same thing. 2x times 3x, 2x times negative 5y, negative 3y times 3x, negative 3y times negative 5y. Alright, so 2x times 3x, 2x times negative 5y, negative 3y times 3x, negative 3y times negative 5y. 2x times 3x, 6x squared. 2x times negative 5y, negative 10xy. Negative 3y times 3x is negative 9xy. Negative 3y times negative 5y, 15y squared, positive. Oh, in this one we could add the like terms. The two terms in the middle are called like terms. So a negative 10xy and a negative 9xy is negative 19xy. Okay, so the next one we're going to distribute the 2x and then come back and distribute the negative 3. So 2x times the 5x squared, the negative 3x, positive 2, and then negative 3 times the 5x squared, 3x, and the 2. Okay, 2x times 5x squared is, well, that's going to be 10x to the third. Again, you don't have to show this step. You could just go ahead and do the product. This step right here is just showing all the different products. After a while, you probably don't want to show this step. You probably want to go right to this step. 10x to the third minus 6x squared plus 4x. The first three terms are from distributing the 2x, and then the last three terms are from distributing the negative 3. And then add like terms. We have a negative 6x squared and a negative 15x squared, and then we have a plus 4x and a plus 9x. 10x to the third minus 21x squared plus 13x minus 6. Okay. I mentioned this word earlier. We're talking about two binomials. Many people will say the FOIL method, but it's nothing new. It's still distributing. It's just kind of a nice name we like to put on it. FOIL, it stands for firsts, outsides, insides, and then lasts. But it's really nothing new from what we were just doing. Okay? We're going to pause and write that down. Again, F stands for the firsts, O stands for the outers, I stands for the inners or insides, and L stands for the lasts. All right, so we're still doing the same thing. We'll call it FOIL, but it's the first, so the firsts are 3x times 2x. The outsides are 3x times negative 5. Say the same thing. The inners are 2x times 2. And the lasts are 2 times negative 5. 6x squared. Negative 15x. 4x. Negative 10. Putting it all together, just add the two like terms that are in the middle, the negative 15x and 4x, that's a negative 11x, and you're all done. Again, if you don't want to write out, FOIL, you don't have to. You can just write the answers like we were doing before. All right, here's two more, and these ones just have special products. What that means is, well, you'll see. Let's do the first one. The firsts, 9x squared. Again, you can always pause if you want to make sure you give it a shot before we do it. Outers, negative 6x. Inners, 6x. And the lasts, negative 4. Now look what happens with the two middle terms. Yeah, that's right, they cancel. So in this case, our answer is only a binomial. Go ahead and try the next one. Again, it's another binomial. Notice that they're both squares. Look at the first answer, 9x squared. That's 3x times 3x. 4 is 2 times 2. They're called perfect squares. 25x squared is 5x times 5x. 49 is 7 times 7. And in both cases, there's a minus in the middle. So it's called the difference between two squares. In the next chapter, we're going to go backwards. It's called factoring. And we're going to go from that answer back to what the original product was. So keep this in mind. This is called the difference of two squares. Okay, here's another couple problems to try. 2x plus 9 times 2x minus 9. That's number 8. And then number 9 here, x plus 3 squared. X plus 3 squared, notice that there's an exponent outside. That just means that there's two of them. It means it's x plus 3 times another x plus 3. Okay, this time I didn't write that F, O, I, and L. I just went ahead and started multiplying. See, 2x times 2x is 4x squared. 2x times negative 9 is negative 18x. 9 times 2x is positive 18x. 9 times negative 9 is negative 81. Again, the two middle terms cancel. So it's 4x squared minus 81. Now again, on number 9, you want to write it out twice and then multiply. So x squared plus 3x plus 3x plus 9. The middle terms do not cancel because they're both the same sign. So we're going to add the two middle terms. X squared plus 6x plus 9. There's actually a formula for this kind of problem, but it's easier just to multiply it out. The formula would be called a binomial, the square of a binomial. So formula for the square of a binomial. All right, let's do another one. This one is the cube of a binomial. It's to the third power. That just means we're going to write it out how many times? That's right, 3 times. Okay, now we're going to multiply the last two. Well, it doesn't matter. You can multiply the first two, but it's easier if we multiply the last two. So if we multiply the last two, x times x, x times 2, 2 times x, 2 times 2. And then when we get that answer, we're going to put it in parentheses. And then we're going to take care of that first x plus 2. Okay, so what we got here is, let's see, x squared plus a 2x plus another 2x plus 4. So that's where the 4x in the middle comes from. Okay, now we're going to distribute the x plus 2 that's in front. So that's going to be, so we're going to do x times x squared, x times 4x, x times 4, 2 times x squared, 2 times 4x, 2 times 4. All right, so distributing that x to the trinomial, that gives us the first 3 terms, x cubed, 4x squared, 4x. And then we distribute the 2, 2x squared, 8x, and 8. And then add any like terms. I believe we have a couple of x squared terms and a couple of x terms. Combine those. And we're all done. All right, I'll see you here for the next one. Have a good one.